multiple integral, or let's say here we'll just look at double integral. Now, what does it mean to integrate a function f of x within the interval a to b? Within the interval a to b. Okay, let's see. Okay, now a b f of x dx. Now f of x here is a function. Let's call this f of x. And a to b is an interval on the x-axis. So, if we integrate f of x from a to b dx, what we actually do is we find the area under this curve bounded by a and b. So actually we compute this area. That is the interpretation of that. Let's also interpret the double integral r f of x y dA. F of x y dA. Now, here f of xy is no more a curve, but it's a surface. Okay, so we are looking at some surface in space. Okay, we all know here is y, x, and z. And here R is a region in the xy plane. Let's say a region in the xy plane. Now, if I project this thing up, it will meet our surface. To meet our surface, right? Okay, then we will get something like this. Okay, so this one actually is finding the volume under the surface bounded by this region. If you look on the slides, there's some image there. There's a picture there. Okay, that is the interpretation of double integral or double integration. We use it to find volume under the surface bounded by a region. Okay, now we have two types, or let me say, I'll break it down into two types. We have double integral over a rectangular region and double integral over a general region. Okay. Now we will first look at double integral over a rectangular region. Let me say here we are going to assume that you know integration and your integration is on point. If your integration is not on point, don't worry about the integration. Look at it with an open mind, okay? And please make sure you revise integration quickly, because if your differentiation and integration is not good, you are not good for this class, okay? So make sure you sharpen your integration. Okay, let's move on. If we are integrating over a rectangular region, that is r f of x, y, a. Here we will define r to be equal to a b cross c d. Here a and b is the interval of x and c d is the interval of y. Now you would ask, why do I write the a? The a because now it is up to you to determine whether you want to integrate first with respect to x before y or y before x, right? Okay, so typically if I define a double integral like this, right? Good. And here the region is a rectangular region. Then to set up my double integral, because the function depends on x and y, it means that this a here must be either dx dy or dy dx. If I would want to integrate first with respect to y before x, right? Then the y limits, the inner one, this y corresponds to this inner one, and the dx corresponds to the outer one. So here the interval of y, I said here, this is the interval of y and this is the interval of x. So the interval of y will accordingly come here cb, and that of x will accordingly come here ab. Okay, but setting up this, right? Setting up this, if I draw my region, x is between a and b, and y between c and d. Now accordingly, right, I can see here y is equal to c and y is equal to d, and x is equal to a and x is equal to b. Good. We put the c and d, definitely c is lower than d, so we put c down and d up, and here a down and b up. Now if we say x is equal to a, if the writer crosses here at a, x is equal to b will cross here at b, y is equal to c will cross here at c, y is equal to d will cross here at d. That is why we call here, we call this one rectangular region, because this one here defines a rectangle. Okay, so we call this one here rectangular region. Okay, so now this is the setup. Now there's a theorem called Frobenius theorem, or Frobenius theorem. Now Frobenius theorem says that if I define this, and here my region is a rectangle, and always if it's a rectangle, it will be defined in this form, this format. Frobenius says that if we want to integrate this first with respect to y and next with respect to x, right? Then this one here is cb and here ab. It is equal to dx dy. Frobenius says it doesn't really matter. I can first differentiate this with respect to y and x. Here putting my y limit here and the x limit there. Because now here is now x, I'll put a and b in front now, and c and d. Okay, you may not really understand this, right? But Frobenius is saying that it is, I'm coming a moment. Thank you. Frobenius says that It doesn't really matter which one you do first. We can just swap them. Okay. Let me give you an example for you to understand. If I am to integrate this 2xy, let me say 4xy from the A and this R. Okay, now here R is 1 to 2 cross 0 and 4. Fubini says that if I decide to integrate first with respect to x, let's say y, right? Then I'm going to write this 4xy dy dx. And here, my limit for y is 0 and 4, that of x is 1 and 2. It's the same as integrating 4xy. If I decide to do with respect to x and y, 1, 2, 0, and 4. That's what Fubini says. Right? So this either this or this will give us the same answer. Now, it is only true for rectangular region. This is only true for rectangular region. In other words, once we can write it like this, right? Then once we swap this, we also swap that. And we are fine. Okay, quickly, I will just solve this one for you to see how it's done. Given this, right? We first integrate with respect to y. And if I integrate this with respect to y, I'm going to get 4xy squared over 2 at 0 and 4. Integrating this from 1 to 2 dx. Okay, now the 0 and 4, right? Take the value for only y. So in place of y, I'll put 4, and I'm going to get 4 to the power 2 is 16. 16 times 4 is 64. 64 divided by 2 is 32. So I'm going to get 32x. Minus, when I put 0 in place of this, everything will be 0. So that, right? So I'm now going to integrate 2x dx from 1 to 2. And when I integrate this, I'm going to get 16x squared at 1 and 2. When I put 2 in place of x, I'm going to get 4. So I'm going to get here 16 2 squared minus 16 times 1. I hope you understand. This is just integration. Now, 4 times 16, I think is 128, right? Is it? No. 32 is 64. Okay, so this is 64 minus 16, which is 58. So this means that the volume under this surface bounded by this rectangular region is 50, because this volume is unit cube. Unit cube, right? Okay. Now that is that. Let's do some more. I hope I got the calculation right. If it's not right, you can correct it for me. Yeah. Thank you.